if you have a triangle, and I'm going to color code this one here, A, B, C, is a triangle without a right angle. If you have a triangle without a right angle, you cannot use SOHCAHTOA. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Because that only works with right angle triangles. You are also not able to use a squared plus b squared equals c squared. Pythagorean theorem, a squared plus b squared equals c squared, only works with 90-degree triangles. But we still want to do math with triangles that don't have 90 degrees. So how do we do that? Well, to start off with, we're like, well, I can only do trigonometry with 90 degrees. Why don't I draw a straight line down, call it my height, and make it 90 degrees? That splits my blue triangle up into two triangles with 90 degrees. Seems to make sense, seems to make me happy. Yes, I'm happy. Well, you're always not happy. It's a character flaw. I can at least do math with that triangle. But the problem is now with this green line, I split up side length A to B, so I don't know how long it is. But what they want me to do is they say, can you use triangle A, D, and C to write an expression for the height? Okay, well, if I use angle A, so first of all, I'm going to do this in purple. There's my angle A. If I think about the H, it's the opposite side. I don't know how long A to D is, but I do know that A to C has a length of B. So could I write sine of angle A is opposite over hypotenuse? Sine of A would be H over B. And if I wanted to, I could get the H by itself by multiplying both sides by B. This is step one. Similarly, I'm going to take out my orange pen. I'm going to look at angle B. And now, H is still my opposite side of angle B, but now my hypotenuse in this little triangle is A. So I would know that sine of angle B is opposite, which is H, over hypotenuse, which in the triangle on the right is A. And once again, I could get H by itself by multiplying both sides by A. And we just did something that is and has huge mathematical implications. What we just figured out is if I take the purple box and I take the orange box and I look at them and they're both equal to H, does this make sense that I could say that the B sine A has to equal the A sine B? Do you see that? Because they're both equal to H. This is very powerful. In fact, this is the start of something we call the sine law. With the sine law, what we'll often do here is we'll take this blue equation and we'll rearrange it a little bit. People find it really easy to remember when it's written this way. Because the A goes with the A and the B goes with the B. So this tells me that if I have this blue triangle, that if I take sine of angle A and divide it by side A, it has to equal the same thing of sine of angle B divided by B. And what have I taken out? The H. What does that allow me to do? This is like, here's the powerful part of what we just did. I'm going to draw a triangle. Okay? I'm going to tell you this is 70 degrees. This is 60 degrees. This is 5 centimeters. And I'm going to say, can you tell me how long this side is? We cannot use SOHCAHTOA because it does not have a 90-degree triangle. Technically, okay, we could do this. We could draw this straight down and make a 90 and a 90. Can you see with that, you do not have enough information to solve for the triangle, the question mark on the triangle on the left, because you only know one thing. But on the right, could you use SOHCAHTOA? Yes, and if you use SOHCAHTOA, all I'm going to do is say I could figure out the rest of this triangle with SOHCAHTOA. If I figured out the rest of that triangle with SOHCAHTOA, now I could go here and figure out the rest of this triangle with SOHCAHTOA. That sounds like a lot of steps, and it is, but is it doable? Absolutely. But what we just did was we just said, hey, I just made a relationship where I could skip finding H. And instead of doing all of those things, I can erase all those lines. I'm like, that seems like a lot of work. I still want to find this question mark. But now this relationship says that if I have sine of 70 degrees and its opposite side is 5, it has to equal sine of 60 degrees and its opposite side was the question mark. Could I do math to get question mark by itself?
Yeah.
Yes, like a question mark, I'll move it up over here. I'll move that sine 70 down over here. I'm going to keep the sine 60 here. I'm going to take the 5 and move it up over. Oh, look at that. I got the question mark by itself. I did a lot of algebra really quickly there. We're going to practice that slower, don't worry. And I can type that into my calculator relatively easily. Harder to say, I guess. Five sine 60 over sine of 70. Enter. It's 4.608.
You forgot the back, not like.
I think I put the 5 in there, didn't I?
Did. Are you the same answer now? 5.
Let me see if I typed the 5. Let's go back. The 5's there. It just looked like a big S to you. See? Fine. It's just a 5. Okay? Very cool. Very powerful. And in fact, what is also, here is the complete sine law for you. I could have also decided to draw my H like this. And make a 90 degree there. And then use angle C and angle B instead of angle A and angle B. If I used angle C and angle B, this same equation would show up. I would have B sine C equals C sine B. It would work out to be exactly the same. And if I rearrange this one, I would get that sine C over C has to equal sine B over B. Now B, it's just like switching the letters around, but I would do the exact same thing with a different height. And this is your sine law in its entirety. Because if sine A over A is equal to sine B over B, and sine B over B also is equal to sine C over C, then all three of these are equal to each other. And you can use any two that you want. It's the only formula that has two equal signs, but really those two equal signs says whenever you want to use it, you just pick whichever two you want. Okay? Question for you. If 2 over 7 is the same as 4 over 14, which is true, right? Is it still true if I flip them? Is 7 over 2 equal to 14 over 4?
Yeah.
Yes. So the sine law has two different forms. You can either put the signs on the top, or you can put the sides on the top. And we can now say goodbye, SOHCAHTOA. We can now do triangles without 90 degrees as long as you know three pieces of information. So my blue triangle that I did as an example, I knew three pieces of information, and what was important for the sine law to work, two of those have to be opposite of each other. Because in the sine law, angle A goes with side A, angle B goes with side B, angle C goes with side C, and those are always opposite of each other. An angle and its opposite side. The letters don't matter. I'm going to give you a new triangle that has P, Q, and R. You're like, oh, my formula has A, B's, and C's. Who cares? The important thing is that angles go with opposite sides. If you start to worry about the letters, you're going to stress yourself out. Yes?
I also can only find the opposite side of the angle that I've also included in the formula.
Right, so the,
So that's what
like with this one, the only thing I could find is the opposite. However, what do you know about triangles?
I mean, I can.
They add up to 180, so could I find that? Yes.
Yeah, and then I can.
And then you could find this one? Yes. And we can solve the whole triangle.
I just have to make sure
Yeah.
that it's the right angle.
Oh. And guess what I did? Yes, sir. You won't, if you think hard enough, you will look at the smile on my face.
I just want to put a video.
I watched the squirrel movie.
Good.
That was amazing. That was so good. If you haven't watched the whole 22-minute version.
This one's in class.
No, but it's so valuable, you would be like, it's worthwhile watching it outside of class. I want to sit at home and watch it with my whole family. Squirrel obstacle course, make sure you look it up on YouTube, it's so good.
That by model.
Yeah.
That's videos to
Okay. All right, there's my plug for watching a YouTube video during my class. What is also cool about this is it creates for us a new area formula. What is the area of a triangle? Right, you already have this memorized. 1/2 base times height. Okay? Now, what did we just figure out? We just figured out a way to switch the height. Right? So, I can take this formula. I guess if I'm switching the height and I'm using B, I'm going to actually take my triangle here. This was side B. This would be the height then, right? This was A. This was B. This was C. Okay? How do I figure out, I can take this, I know that bothers you with the height that way. I'm going to take that height for you, right? Because our brains don't like heights that are not heights. And I take that for you and redraw it as a height, what do I have to do? I have to rotate that triangle. If I rotate that triangle so that the base is here, makes sense that my side B is now at the top. I'd have to rotate it this way. No, my side C. Oh, I screwed up when I made the letters. I'm sorry. Okay. Yeah, here's the original. This was B, this was C. I just redrew my original triangle that I had here, but I drew this new height this way with a 90-degree here. If I rotate that, B would be at the top, A would now be over here, right? And C would be over here. Okay? So if I take angle C, sine of C is H, this would be little a over A, so H is equal to A sine C. Same thing we did with the other ones. But now I can take my formula and replace the H with A sine C. And now if you have, I like to rewrite this one with the letters in alphabetical order because it makes it really easy to remember, A, B sine C. You have a new formula for the area of a triangle. And I could give you a question like this.
All balls.
With sides of 6 and 9. What is the area of this triangle? What's the problem with our old formula? Our old formula says 1/2 base times height. I don't know the height. I can't find the area. I could draw the height and do math, but I could find it. But now I have my new formula that says 1/2 AB sine C. The angle I have is 30 degrees. That's the angle that I have. The angle would go with, if this is C, side C is the opposite one. So one of these is A, one of these is B. It doesn't matter which is which. All right. How are we feeling mental math-wise today? Okay. How did I do this? These are centimeters. I did that in my head. Type it into your calculator to check, see if I'm not lying. Just going to say something with a swear, but I can't say that on video.
It's going to go.
Just turn it off. No, I'll be good.
Yeah. It's correct.
It's correct. Oh, I must have just got lucky. Or how did I do this in my head?
You know that sine of 30 is half.
That's one of our values. We know this
You
is a half.
memorized it.
No, we don't.
You memorized it.
You should.
Okay.
I did it in my head too.
All right. 6 times 9 is 54. 54 cut in half is 27. Cut in half again is 13.5. Look at that. But now you can find areas of triangles that don't give you the height, as long as you have an angle and the two sides right next to it. That's how this new formula works. This new formula is on your formula sheet and has to be committed by memory by the end of grade 12. So may as well memorize it already. Or don't memorize it and do what we just did. We just made it.
This is easier.
Making it is easier, okay? So we have, what we have right now is we have introduced, I have it at the bottom page here, this whole thing is the sine law. It is on the next page, bottom page 471. And the key to the sine law is not worrying about what the letters are, but recognizing that in each fraction you have an angle and its opposite sides. So it's very important in trigonometry that we're going to be doing with triangles that are not right-angled triangles is recognizing that angles and opposite sides have a relationship. So we're going to use the sine law when you know an angle and its opposite side. And if you have one more piece of information, you can figure out everything. So with that, we are going to go to example 1. And we're going to figure out, can we use the new beautiful sine law? We cannot use SOHCAHTOA. Be careful, you're going to be tempted to use SOHCAHTOA. If you use SOHCAHTOA and you're not allowed to, it's very easy for me to mark. I just get to give you my choice of whichever size of 0 I want. Right? Little zeros, big zeros.
This put the
Right.
value first of it.
So you cannot use SOHCAHTOA, or you might be tempted to use a squared plus b squared equals c squared. Right? If you do it on the whole page, I just give you one big 0 on the whole page. So we got to be careful. Okay? Next, sometimes you can use sine law, sometimes you can't. Your way of determining this is, do you know an angle and its opposite side in this example? Yes. I'm going to circle them in purple. Right? Here's an angle, here's its opposite side. I can use the sine law. Now the sine law was 6 things equal to each other in one, or 6 other things equal to each other in the other one. How does this work? How do we use it? Okay? How do we know, should we do the one where it's the sine on the top, or should we do the one where the side is on the top? And it's actually, for setup purposes, it is going to be really easy. Ask yourself, what do you want to find? In this question, we want to find the length of GH, which I'm going to highlight here in orange. G to H would be this length. It's labeled with a little letter J because it's opposite of angle J. Whatever you want to find, write that on the top of the fraction first. And the sine law always works with opposite angles and sides. So if I write J here, then I'm going to have to write sine of something on the bottom. What goes with J? 44. Equals, the ones that we know in purple, well, I'm putting the sides on the top and the sine on the bottom. 7.8 has to go with 51. If we put what we want to solve for in our numerator, our algebra is just easier. You could have had the J on the bottom, and you have to do more algebra, which, if you like algebra, maybe you want to do that. But now, if I want to get J by itself, right now J is being divided by sine of 44. What is the opposite of dividing by sine of 44?
Multiply by sine of 44.
We multiply both sides by sine of 44. And most people won't show this. I'm showing it now, but I would be fine if you immediately went to this next step where you got J by itself. And you wrote J is equal to 7.8 sine of 44 over sine of 51. And we can go to our calculator and type this in. Did I write that incorrect? Yes. Push enter. 6.972. Okay. Do I have units? I better include them. Have I rounded correctly? Nope. I better. How How do I round this to the nearest 10?
6.7.
7.8.
You have to write 7 and you have to write the point 0. Double dot. There we go. 7.0 centimeters. Circle my final answer. We just solved our first triangle that wasn't 90 degrees. And the sine law, for those of you that were hoping was going to be really, really hard to use, unfortunately it's not. Unfortunately, it's easy to use. You just have to have this connection that angles go with opposite sides. So whatever we're trying to solve here, I wanted to solve J. I start with that in the top. What goes with J? Oh, the 44 has to go with J, sine of 44. And you don't have to worry about the A, like, this question is like, oh no, I can't use my formula, because my formula has A, B's, and C's, and my question has G, H's, and J's. What am I going to do? You're going to be just fine. The key to making the sine law simple is knowing that angles go with opposite sides. As soon as you start worrying about the letters, yeah, if you want it more difficult, make sure you use the right letter. That makes it hard. Okay? Okay, questions you can circle. Circle question 3. And we'll get